Hi, Addie. Today's lesson is super fun. I think you're gonna really like this one because it turns really complicated looking problems into something doable. And so it's fun. I think it's fun for that reason. I think you're gonna love it. Okay, let's jump in. We're gonna talk about product rules when we're talking about exponents. So product rule for exponents. And then we're gonna talk about addition of like terms with exponents, and then you'll see how these two topics are related and how a lot of people are gonna get them confused, but you are not gonna get them confused because you are awesomely really good at math. All right, let's jump in. First of all, so is macaroni and cheese, this isn't a joke. This is just kind of food for thought. Get it? Food for thought. Okay, is macaroni and cheese mac because it's short for macaroni, or is it because MAC is an acronym for macaroni and cheese? So an acronym is a word that you make from the first letter of each word. So I don't know. I don't really know the answer to that. So text me and tell me what you think. Is it short for macaroni or short for macaroni and cheese as an acronym? I don't know. But either way, we're going to just let's get down to business here. That awkward moment when someone says, let's get down to business. And now all you want to do is defeat the Huns. All right, I'll stop with that. All right, the product rule for exponents. You can figure out what the product rule for exponents is when I show you a couple of examples. For example, you know that 3 raised to the 5th power is actually 3 times 3. How many 3's are there going to be? There's going to be 5, right? Because it's 3 raised to the 5th power. So you get that. You know what that means. Now, what if we're multiplying two of these things together? Well, we'll start with 3 raised to the 2nd power. 3 raised to the 2nd power is 3 times 3. Okay, now what about 3 raised to the 3rd power? Well, 3 raised to the 3rd power is 3 times 3 times 3. See what I did there? So 3 to the 2nd is this part, and then we multiply that by 3 to the 3rd, which is this part. How many 3's do we end up having? We have 1, 2, 3, 4, 5, which is funny because that's the example that we started out with. So now we know that 3 raised to the 2 power times 3 raised to the 3 power is the same as this. So this whole thing can be written as 3 raised to the 5th power. Okay, that's cool. Cool enough, right? But how do we get that if you don't want to write a bajillion 3's every time? Well, look at this 2 plus 3. Oh, now you can see what we're going to do here, right? Okay, here's another example. What about 3 times 3 to the 4th? Well, 3 is just a 3. I mean, it's just a 3. You're not multiplying it by anything. But 3 to the 4th, if I were to write that out, it would be 1, 2, 3, 4. This is also another example of 3 raised to the 5th. Because look, 1, 2, 3, 4, 5. You have 5 3's. So that's the same as 3 raised to the 5th. So I can write all of this just as 3 raised to the 5th power. And check it out. Look at these exponents here. You've got a 4 and you've got no exponent, which is a 1. Oh my goodness, 3 raised to the 5th. You can see what we're going to do here. This is so fun, right? Okay, so you can see that when you multiply exponents and, oh, here's the other thing. The bases have to be the same. Remember, this is the base, this 3, and the exponent is this part. So if the bases are the same and you're multiplying those things together, then the answer that you're going to get, the product of that, is obtained by adding the exponents of the factors. Okay, if that's all you learn from today, that is a major lesson in math, okay? Because here, let's check this out. What if you have a really complicated problem that looks like this? You're multiplying x to the 5th times x to the 7th times x to the 2nd power, or x squared. All you have to do to figure that out, because there's a couple things that have to be there for this rule to apply. You have to be multiplying these things together, right? So you have to have a multiplication sign here, either a dot or an x, right? Okay, the other thing is the bases have to be the same. These bases are the same because they're all x's. So since they're all x's, and since you're multiplying them together, this becomes so easy. All you have to do is add 5 plus 7 plus 2. And the answer is going to be x raised to the 14th power. Oh my gosh, I love it. I love it. You're just adding. It looks like something so hard, but we're just adding. Let's do the next one. So does the rule apply? The bases are the same. You've got a bunch of 5s, and you're multiplying all these things together. So what I'm going to do is I'm going to write the same base, and then I'm just going to add the exponents. What is 2 plus 3 plus 2? Wham, bam, we got a 7, right? 5 raised to the 7th power. And what that really means is 5 times 5 times 5. There's going to be 7 of those, right? How many is that? I think that's 7. So that's what it means if you were to write all of that out. And you can see that that's true because we have 5 squared, that's these two. We've got 5 cubed, which is the next 3. And we've got another 5 squared, which is the last 2 5s. So it makes sense that this is 5 to the 7th. I love it when math makes sense, right? Let's do the next one. Oh, I'm having so much fun. Okay, what about p raised to the 5th power times p to the 12th? Okay, we're multiplying, so that's cool. The bases are the same, so that's cool. So all we can do is write the base, add the exponents. What is 5 plus 12? 5 plus 12, 17. Here's your answer. Done. You're going to be done with this homework in no time, right? Ha, awesome. All right, one more. Now this one seems a little bit more confusing because they're multiplying 3 things together, but we've done that. We can do it. Are the bases the same? Yes. Are we multiplying all these things together? Yes. Therefore, I can write the same base and I can just add the exponents. 2 plus 3 is 5 plus 25. Whoa, that's a big, ginormous exponent, but we just add it just like we do all the other ones. So we've got 4 raised to the 30 power. So to summarize all of that into one rule, it is this. This is what you have to have memorized. Okay, this is the product rule for exponents, and it basically says if m and n, get it, M&Ms? No. M and N's this time. If m and n, so what are m and n? Well, it's just the exponents. They're just referring to the exponents, and they gave it letters that are not x. Okay, so if m and if n are real numbers and they're not equal to 0, okay, something different is going to happen when they are equal to 0, so we're just going to ignore that for now. Let's just say they're not equal to 0. X raised to the m power times x raised to the n power is equal to x, that's your base, and we're going to add the exponents m plus n. So this complicated thing, if I were to show you that first, you would be a little confused. But since we did those examples first, now you totally get it. X raised to the m times x raised to the n is equal to x m plus n. Super easy. Let's do some examples and make sure that it is as easy as we think. All right, let's start with example 21.1. If you're following along, this is in page in the top part of page 92. All right, so here's the example. They give you a bunch of letters. Oh my goodness. They want you to simplify this expression. And you can tell that it can be simplified. These are just written all smushed together, but that basically means that you're multiplying all these things, right? And this is all one term, but these are different expressions within that term, right? You've got an x and you've got a y. And just like with any term, what you're doing is multiplying all these things together. So you could kind of spread it out if that makes it easier for you to visualize that. But I'm just going to scan through and look for things that have the same base. So for example, here's an x. Is there another x? Yes, there is, right there, x raised to the 5th power. So I can simplify this by pulling out the x's. Okay, I'm just going to focus on the x's for now. Focus on the x. Okay, and I've got x squared right here and x to the 5th. If I'm multiplying those things together, which I am, then I just write the base, which is x, and add the exponents, which is 7. So now I've basically taken care of this and taken care of this. So I'm going to cross that out so I keep things straight in my mind. What do I have left over? What I have left over are the y's. So I've got y squared and y cubed. So I'm going to write a y over here for my new term. I mean, it's the same term, it's totally equivalent. So that's what we're doing. We're just simplifying it. And then I'm going to add the exponents. I'm going to add a 2 and I'm going to add a 3. And the answer I get, 2 plus 3, 5. So did you realize, okay, then I'm going to cross that out just to make sure that everything is crossed out. That means that I dealt with everything in that term and I'm not forgetting something. Because what if there's like a random P in there or Q? Then you've got to just write that over here if there were one, but there's not. Okay, so this is the answer. And that expression is actually equivalent to this expression. It's totally the same thing. It's just simplified. All right, let's do another one just to make sure that you get it. Oh, another thing. What some people do to make it easier is they'll take something complicated like this, x squared, y squared, x to the 5th. And if you want to, well, I mean, it's not really adding a step, but you can move these things around. Why not? It doesn't matter the order with which you multiply things, right? The order doesn't matter. You can do 5 times 3 or 3 times 5, you get the same answer. So if you do x squared, so this makes it so that you kind of put all the same terms together, and that way you won't forget anything. And then you can just do, well, this is x raised to the 7th power, and this is y raised to the 5th power, and do it like that. So if it helps you to move things around, it's kind of an extra step. I kind of do it in my mind and then just cross things out as I go, but you can do it this way too, and that's how they do it in the book. All right, let's do another example. This is example 21.2. They want us to simplify this complicated looking expression. So maybe this time I'll rearrange the factors first just to show you a different way of doing it, okay? So I'm going to take this, whoops, how about I take the whole x? I'm going to take the whole x squared, and put it right there. And then I'm going to, if there are other x's, I'm going to pull those out and put all the x's together. Then I'm going to move this m to the end. So I'm not changing anything in the term. It's just all multiplied together. Now it's just in a way where, you know, I make sure that I get it all right. All right, so let's deal with the x's first. Okay, x squared times x to the 3rd is going to be x raised to the 5th power. I just added the exponents there, kept the base the same. What about the next part? I have y cubed and y squared. I'm going to make that y raised to the 5th power because 3 plus 2 is 5. Now there's m is left over. There's nothing to multiply that by, and there's no way to simplify it. So in that case, I'm just going to bring it down and leave it the same. And guess what? Easy peasy, I am done. That's my answer. All right, so cool. Here's another definition that you need to know. If something doesn't have an exponent like this, there's no exponent there, the exponent is automatically 1. So there could be an x or a y or something raised to the 1 power, and it's the same as writing it just by itself. Obviously, because x squared means x times x. But if it's x raised to the 1 power, it's just 1x. That's what it means. So that definition totally makes sense to me. It's just something that you have to think about when you're doing these problems, okay? Because you might need to add a 1, right? So let's do these examples and figure this out. So if you have 5 raised to the 1 power, the answer is just 5. If you have 7 raised to the 1 power, that equals 7. If you have x raised to the 1 power, that equals x. Just to kind of reiterate that point. All right, now let's do an example. Let's do example 21.3. They want us to simplify this complicated looking expression. So I'll rearrange the letters again. I don't know if you like it that way, but I'll just do it just to make things a little easier. I'm going to put the y's together. I'm going to put the x's together. Okay, so now that I've grouped everything, let's simplify this. I have an x and an x cubed. This is kind of like, we're multiplying these two things together. And since that first x right here has no exponent, I'm just going to add a 1. Okay, so the rule is still the same. I write the base x, and then I add 1 plus 3, so it's 4. That makes total sense to me. Hopefully it makes sense to you. Now let's deal with the y's. I'm going to get a different color so we don't get confused. We have a y and a y squared that are multiplied together. The first y has no exponent, which means it's just a 1. So now I can write y raised to the third power because 1 plus 2 is 3. And that is my final answer. So easy, right? Okay, let's do example 21.4. Isn't it cool how you can take such complicated looking expressions or terms like this and then simplify it into something manageable? I love this. I love this lesson. So fun. All right, we have alphabet soup here. We've got a lot of letters. So how are we going to simplify it? We can do it. So I'm just going to group them together first. Let's take this P and move it to closer to that P at the end. Let's also move this M and move it over here. And then this M squared and move it here. And I'll just move these x's closer to each other. And then I'm just going to remember that this is all one term multiplied. Nothing's added. This is just all multiplied together. All right, let's deal with the m's. I'm going to bring down an m because the bases are the same, only here. We're not combining anything that is not the same, right? Don't combine apples and oranges. We're just combining m's with other m's. All right, so we've got a 1 and a 3 and a 2. So 1 plus 3 is 4, plus 2 is 6, so this is m to the 6. Now let's do the x's. X is x to the 1, I'm doing this part now, and x to the 3, so I'm going to end up with x to the 4th power. All right, sweet. Now let's do the p's. I've got p to the 5th and just a p raised to the 1 power since there's no exponent. So that's going to be, p raised to the 6th power. And that is my final answer. Easy peasy, right? So easy and fun. That is super satisfying to me. Do you like it too? Tell me if you do. Send me a text. I'm curious to know. Oh, for example, if we're correcting your homework and this is the answer that you get, but the answer in the book says M6P6 X4, guess what? It's the same answer and you got it right. It's also the same as X4P6M6. As long as the right exponent went with the right letter and they're all multiplied together, it's the same. These are all equivalent terms. And there are actually 6 different ways that you can write these, and there are 6 different ways that they are correct. None of them is preferred. You don't have to put it in alphabetical order. You don't have to do it any certain way. You don't have to, nothing. It doesn't matter. You write this, great. Write that. I'm happy. It's the right answer. All right, let's move on to a totally different topic. I want you to forget, no, don't forget it. Just set aside everything that I already told you because this seems like it's going to be the same thing, but it's not the same thing. So before we were multiplying things that have the same base and have exponents. Now we're going to add like terms with exponents, and that's different. You do totally different things when you're adding 2 numbers and when you're multiplying 2 numbers, right? So just like that, it's going to have, these are different rules. So for example, I started out by showing you an example last time, and I'm going to start out by showing you an example again this time. Okay, the rule is different. When we add like terms mean that the bases are the same, okay? So there's an x squared and an x squared. But what you do is you don't add the exponents this time. I'm going to show you why. This is the term that is the same, the x squared. Everything except the coefficient is the term that is the same. So the x squared and the x squared, when you add them together, you keep x squared. And what you add are the 3 and the 2. So this is 5x squared. So it makes sense to me that we're adding the 3 and we're adding the 2 because this is the same as, how can I simplify this? It's kind of like adding 3a plus 2a and you get 5a. Okay, now when you add it with exponents, you don't change that rule. The exponents goes with the letter and you keep that the same. You might be tempted to add these together, but this is not x to the 4th. It is not. You keep it the same because it's part of that like term. Okay, so, that can be confusing. Is it confusing to you? Adding and multiplying are often confused, and that's why they actually put it in this same lesson at the same time, because we want to point out the difference between these things. When we add, we can only add like terms. We can only add like terms. So for example, this is one term, okay? This is also one term, but take a close look at the letters. And remember how we said when you get the answers, it doesn't have to look exactly the same and it can still be correct? These are actually like terms, this one and this one. Why are they like terms? Because the p is raised to the 5, the x is raised to the 2, or squared, and the y is by itself. So you can rearrange this to look exactly like the other answer. Let's see if I can. Yeah. See, so this is the same as this. It's the same thing, it's just rearranged. So this is a like term, and if they had a number in front of it, like a 2 and a 1, then you could add them together and you could get 2 plus 1, and it would be 3 times this complicated term. But you keep the complicated term the same, because it's just like saying 2a plus 1a is 3a. You don't change the a. This whole thing is the a. This is the like term. Okay. All right, so that's different when you multiply. When you're multiplying two a's together, you get a squared. So the rule is different when you multiply, but when you add, you keep those variables the same, and you can only add like terms. You keep the variables the same, you can only add like terms. Here's another example of like terms. You've got these two things which look different on the surface, but if we move this y squared to here, then you can see that this is actually the same as that, right? They're the same. All I did was rearrange. So they're the same, and if they're the same, you can add them together. You would add them together by saying, well, maybe there's 2 of these and there's 3 of these. You add, and you get 5 of that complicated term, y squared, x, p, 5, whatever. All right, let's do some examples, and maybe it'll be more clear, because I don't think I explained that very well. But it's okay. You are smart, and you can figure it out even when I don't explain it very well. So let's just try it. Let's try simplifying by adding the like terms. Okay, and then they gave us this really complicated looking problem. The first step is to figuring out, well, what are the like terms? Let's start with this term and see, is there any other term that is its twin? It has to be a twin. Now, we're not looking at these coefficients in front. We're going to ignore those. It's just the variables that we're looking at. It's just the letters. So this has an x squared. This doesn't have an x squared. This has an x squared. So could these two be twins? Yes, I think they could, because they've got 5 p's and 1 y. Yes, that is the same. These are the same terms. Okay, so if these are the same terms, let's add them together. This has a 3 out in front of it, and this has a nothing out in front of it, which means what? It means a 1. A 1. So if I add these two terms, 1x squared yp to the 5th and 3p5x squared y, then I'm going to get 1 plus 3 is 4x squared yp to the 5. Now, I dealt with this and I dealt with this. Now, those are dealt with. I don't have to deal with them anymore. Ooh, I do have to deal with this negative sign though. Let's take that. Okay. All right, let's forget the negative. Oh, okay. Yeah, that'll work. Okay. Just because that goes with that one. All right, here we go. Let's look at the rest of the terms and see if they are like terms. They're all mixed up. They're not in the same order, but if I start with this one, I've got an x. I do have an x here. Good. That's a good start. I have y squared. I have a y squared here. Yes, we're getting there. I have a p to the 5th here. And do we have it? Yes, we have a p to the 5th. Therefore, this is a like term with this one. Hallelujah, I can combine them. Now to combine them, the important thing is that we're adding the coefficients. So we're adding 2 plus -7. 2 plus a -7 is what? -5. -5. And then I just write the variables the same. And it doesn't matter how I write them. Doesn't matter. I'm just going to choose this first way that went with the 2. X, y squared, p5. Bam! Now, we just simplified 4 terms that look confusing into 2 terms that also look confusing, but they're a little more simple. And that's how you simplify this. Cool, huh? All right, let's do another example, example 21.6. And it says, simplify by adding these like terms. Woohoo! I had to write small because these terms are long and confusing. How many terms are there? Let's figure that out first. So there's 1 here. There's a plus 3. This starts 1 here. This one starts at -10, okay? And then this a plus. That one doesn't have a coefficient, so it's basically just a 1 right there. So there were 4 terms. All right, so I'm just going to start with this first one. And let's see if there is a like term compared to that. Well, I see an M3. Where else is there an M3? Well, turns out they all have M3s. Maybe they're all like terms. We'll have to figure that out. What about an X? I only see 1 X in this term. I see 1 X in this term. I see 1 X and 2 X's. So that one's out. That is not a like term. But it could be this or this. All right, what about Y squared? Y squared, that matches. Y squared matches here. And what about a P? This matches, this matches, this matches. Okay, so this is interesting. The first 3 are like terms. I wasn't expecting that. Wasn't expecting that, but now we know. Okay, so since the letters, the variables are the same, they're just in different orders, all we have to do now is think about the coefficients. So you've got this coefficient of 2 plus 3, that's going to get you to 5. 5 minus 10 is -5. So the coefficient is -5, and all I have to do is write one of these expressions, m3 xy squared p. It doesn't matter what order because this is equivalent to any of them. We just figured that out. And now that we combined all 3 of those, I feel good about crossing them out. All right, now let's look at this last expression because we have not dealt with this one yet because it's not crossed out. We've got a y, which we do have a y here. We have x squared. Oh, no, we don't. We have a single y and a squared y. So that's not going to work. This is not a like term. So all we can do if it's not a like term is just let it tag along at the end. You have to add a plus sign because it's just tagging along. It's not part of this one that you multiply. It's just tagging along. So that's what you do with that. Alrighty. And that's the final answer. Boom, this complicated long thing. Let's do the next one, example 21.7. It says simplify by adding like terms, and you can see that we have 1, 2, 3, 4, 5 terms. They're not all like terms, but let's figure out how many like terms that we have. Okay, so I like to start just left to right, you know, because whatever, I'm American. Let's start at the left. 2x squared y. Is there an x squared y? Is there another x squared y? Okay, so this is an x squared y, so that counts. This is an x squared y squared. Oh, nope, that's not going to work. Not going to do that. This is an x squared y. Yes, that counts. This is an x squared y squared, so no, that one's not going to work. All right, so I have 3 that count. I have this first one, I have this one, and I have this one, and I'm going to circle that negative that is in front of it. And I'm also going to pay attention to the fact here that there's a coefficient that we can't see, this invisible coefficient of 1, because you don't need to write it every time, you know, but there's a -1 right there. And that's going to make my life easier because I won't mess up the problem. So now, the variable part of it is the same. I'm just going to write the variable part of it. X squared y. How many x squared y's are there? Well, there are 2 here. There's 3 here, so 2 plus 3 is 5. And then there's -1 here. So 5 minus 1, I'm down to 4. So I'm 4x squared y. Sweet. I think I took care of all of those, so I'm going to cross them out. Now, what do I have left? I've got this x squared y squared, and I have another x squared y squared. This first one doesn't have a coefficient, so let's give that little guy a coefficient of 1. Okay, that makes me feel better. All right, so let's see. For my answer, I would put plus, and I'm going to leave a blank for the coefficient because I don't know what it is. But right now I'm adding together the x squared y squareds. How many are there? There's 1 here, and then there's -4 here. So the answer is going to be -3. And that's how many x squared y squareds there are. All right, so this is the answer. This is it. You've done it. You've simplified it. It doesn't look simplified, but you actually have simplified it. I think this lesson is actually super fun, and I hope you love it. So if you love it, don't forget to like and subscribe this video and share this video. And I don't get anything out of it. Don't do that. Okay, just love you, Addie. You're the best. I am excited to see what you can do with this homework assignment. All right, see you later. Bye.